Okay, good morning to all of you. In this class, we are going to discuss about normal distribution as a limiting form of binomial distribution. In our last class, we have been discussed in detail about introduction part of the normal distribution. Uh, what is its PDF? This is the PDF of the normal distribution, and if graphical representation by considering different mean value and same standard deviation. This is the graphical representation of different standard deviation having same mean value, and these are the basic properties of normal distribution, and this is the characteristics core of the normal distribution. So now we are going to go for the normal distribution as a limiting form of binomial distribution. So here, the normal distribution is another limiting form of the binomial distribution under following conditions. That as we know that the PMF of the binomial distribution is your NCX p to the power x q to the power n minus x. This is your PMF for binomial distribution. This is the n represents the number of definite trials. P is belongs to success, q is belongs to failure. Okay, or head tail like that. But if this PMF is going to be follow that the number of trials are indefinitely large, that means n tends to infinite, and P and Q whatever we have in case of your binomial distribution that not to be very small. If these two conditions will be follow, then the binomial distribution will be called as your normal distribution, or you can say with these two conditions binomial distribution will be follow uh, will be followed the normal distribution. So here we are going to prove that one. We know the PMF of BD, with BD means binomial distribution, with parameters n and p is given by px capital P capital X equal to small px is equal to ncx p to the power x into q to the power n minus x. We know very well. So ncx can be written as n factorial by x factorial into n minus x factorial into p to the power x into q to the power n minus x, and here x equal to 0 1 2 and so on up to n. Okay, let us now consider the standard binomial variate. What is that? Consider z equal to x minus uh, e expectation of x by root over of variance. Okay, here z is represents one standard variation or variate. Here see, expectation is a constant, and here root over of variance is itself a constant. So whatever we have this value, from that we are going to be subtracts mean divided by some value. So it will be give you one number. Okay, it will give you a number. Suppose we consider that is your z, that is your x minus expectation of x by root over of variance or standard deviation, or we can write x minus mu by sigma is equal to x minus, we know that mu for your binomial distribution is nothing but np, and sigma or standard deviation or variance we know in case of your binomial distribution is your npq. So obviously sigma will be root over of npq whatever here it has been written. Let this is your equation number 2, and this is your equation number 1. Now when x equal to 0, you just put x equal to 0, z will be equal to how much? Here x equal to 0 or here x equal to 0 minus np by npq root over, or here n root over of n is at the denominator, so it will be np by q whole root over minus. Now if we are going to be consider x equal to n, if I am going to put over here, then z will be equal to n minus np by root over of npq. So here you can take common n from these two terms. We can get n into 1 minus p, or 1 minus p is nothing but your q, so nq. So nq by npq, we can get nq by So it will be nq by p, mistakenly I written q, nq by p. Okay, because it will be n into q. So n into q by, already n p q is there, so q will be cancelled, so nq by p, root over. Okay, root over of nq by p. Okay, so here you can see that in the limit of as n tends to infinite, here if I am going to put n equal to infinite, then z will be minus infinite. If we are going to consider n will be plus infinite, z will be plus infinite. So if we are going to consider limit n equal to infinite, z takes the value from minus infinity to plus infinity. Hence the distribution x of the random variable will be continuous distribution over the range minus infinity to plus infinity. Now to find out the limiting form of the equation number 2 by considering these two conditions, by form of equation number 2 under the above two conditions, what it will be if we are going to consider this one by considering these two conditions, that means n tends to infinity and pq not to be very small, then what will be this will be approach to the normal distribution. At last it has been proved. Okay, this is one of the important question itself. Okay, this is one of the important question. Many times you can found in your exam, uh, that means in your this semester exam. Okay, so carefully you have to watch and write down the note all perfectly. So here we are going to be consider, before we are going to be do the derivation. So here we have to consider Starling approximation for r factorial. Suppose r is a very large number and factorial of r will be how much? By Starling approximation we are going to be consider here. According to Starling approximation, for large r is, for large r, for large r, for large r comma limit r tends to infinite r factorial, or you can write by Starling approximation for large r factorial will be equal to this much. No need to write because large r means it means that r tends to infinite. Okay, okay, no problem. You write in this way, no problem. So here it is written that according to Starling approximation, if r is large, that means if r tends to infinite, then r factorial will be root over of 2 pi e to the power minus r into r to the power r plus 1 by 2. Okay, r to the power r plus 1 by 2, this one. So now in our case n tends to infinite, consequently x tends to infinite. If number of trial will be infinite, then corresponding the values of the random variables, this one will be approaches to the infinite. If n tends to infinite, this possible values, x possible values will be tends to infinite. So now we have to consider uh, consider the equation number 1 for limit x tends to infinity, and right hand side as both n and x both are there, so n tends to infinite, x tends to infinite we can write. So that means here this line represents the limit of x tends to infinite of your equation number 1, this one, is equal to limit x tends to infinite, n tends to infinite. So instead of writing limiting value, so commonly it is x tends to infinite, n tends to infinite already written over here. So you can write just limit px equal to limit n factorial by x factorial into n minus x factorial into p to the x into q to the n minus x. So you just in bracket you write equation number 1 considering the conditions. Okay, considering the conditions. So now limit, here you just keep in your mind, here limit is written means here n tends to infinity as well as x tends to also infinity. Okay, so here n is very large, so according to Starling approximation, it is if r factorial will be 2 pi to the power 1 by root over of 2 pi into e to the power r into r to the power r plus 1 by 2. Likewise n factorial will be how much? Root over of 2 pi into e to the power minus n. See here e to the power minus r, so e to the power minus n into n to the power n plus 1 by 2. Here you can see r to the power r plus 1 by 2. So here n to the power n plus 1 by 2 into p to the power x into q to the power n minus x. Now x is also very large, tends to infinite. That also is will be followed by the Starling approximation. That is your root over of 2 pi e to the power minus x into x to the power x plus 1 by 2. Right. Then this n minus x is also very large. That will be also followed by the Starling approximation. So it will be root over of 2 pi e to the power minus n minus x into n minus x to the power n minus x plus 1 by 2. Okay. Now limit, that implies limit px equal to limit. Here you can see that 2 pi got cancelled. We got 1 2 pi 1 by 2 pi. Okay. And here you can see x to the power x plus 1 by 2, x to the power x plus 1 by 2, n minus x to the power n minus x plus 2, n minus x to the power n minus x plus 1 by 2, 1 by 2. Okay. And here you can see this term with this term is going to be cancelled. See here e to the power minus n, here e to the power minus n minus x, so 1 minus n we can get, so got cancelled. And here e to the power minus x, this will be e to the minus minus x, e to the plus x, so this e to the plus x, e to the minus x, so automatically e to the 0 will be 1, so this term will be cancelled. Okay. Now what we got the n to the power n plus 1 by 2, p to the power x, q to the power n minus x. This much can be written as np to the power x plus 1 by 2 into nq to the power n minus x plus 1 by 2 divided by npq whole root over. You just check that npq is there. That means 1 by npq into, I am going to consider suppose this one, np to the power x plus 1 by 2 1 by 2. So here np is there, so if I am going to take this to the numerator, it will be how much? It will npq to the power minus 1 by 2 into np to the power x plus 1 by 2. So you consider np to the power minus 1 by 2 into q to the power minus 1 by 2 into np to the power x plus 1 by 2. So you just consider these two terms. How much you can get? You are going to get that np to the power np to the power x, see minus 1 by 2 plus 1 by 2, so only x, and q to the power minus 1 by 2, right? Now this term is there, that is your nq to the power n minus x plus 1 by 2. Okay. Now here nq to the power x, nq to the power n minus x plus 1 by 2, you just add these two. So here first we have to add the power of the n. So here n to the power x and n to the power n minus x plus 1 by 2. So we are going to get here x got cancelled. If I will add x got cancelled, and we are going to get n to the power n plus 2, n to the power n plus 2, whatever we have here. Okay, n to the power n plus 1 by 2, n to the power n plus 1 by 2. Now we are going to be consider p to the power x. Here p to the power x is there, p to the power x we got, and here q to the power 1 by 2 minus 1 by 2 plus n minus x plus 1 by 2. That means q to the power n minus x, whatever we have here. So this numerator with adjust or represented either way as np to the power x plus 1 by 2 into nq to the power n minus x plus 1 by 2 whole divided by npq root over. Okay, now from equation number 2, so this is your equation. Let this is considered as equation number 3. Now consider the equation number 2. Where is the equation number 2? Yes, this is your equation number 2. So equation number 2 is represents z equal to x minus np by root over of npq. So this is your, from that equation number 2, x will be how much? X will be z into npq plus np, right? So x will be np plus z into root over of npq, right? Now further, if we are going to consider n minus x, that means n minus this much minus this much, then we can get here n into 1 minus p minus z into root over of npq. 1 minus p is nothing but q minus z npq root over. So here n minus x divided by nq. See here, if I am going to be take common nq from this term and this term and divide this side, then this will be 1 minus zq root over of npq by nq, right? Here nq root over of nq divided by nq, and root over of p is already there. So p by, we are going to get p by nq whole root over, right? Now we have to differentiate this side and this side. So it will be n, q, p, these are constant, only x and z are the variate or variable. So this will be minus dx by nq equal to minus, this is the constant, p by nq root over into dz. So minus minus got cancelled, dz will be 1 by npq root over into dx, or 1 by npq root over equal to j dz by dx. If we are going to consider this one also, we are going to be found 1 by npq root over dz by dx. So why we consider x and n minus x? Because these are the two powers of our equation number 1, x and n minus x. So from that x and n minus x, it is giving the same physical significance or not. Only for that we have been checked that dz by dx here in the, by considering x we got 1 by npq, and by considering n minus x also we got the same value, 1 by npq equal to dz by dx, which will be required in your equation number 3. See here in equation number 3, we have to put, instead of 1 by root over of npq will be dz by dx. Okay, so here therefore equation number 3 will be how much? Limit, that implies limit px will be equal to limit whole into 1 by root over of 2 pi into dz by dx into np to the power x plus 1 by 2 into nq to the power n minus x plus 1 by 2 whole divided x to the power x plus 1 by 2 into n minus x to the power n minus x plus 1 by 2. Okay, so is equal to limit 1 by root over of 2 pi into, here you can see np to the power x plus 1 by 2, x to the power x plus 1 by 2. So we can write np by x to the power n plus x plus 1 by 2, right? So here nq to the power n minus x plus 1 by 2 by n minus x to the power same power. So we can write n cube by n minus x to the power n minus x plus 1 by 2. Okay, and dz by dx we have been written over here. Okay, so now limit px dx. So here dx taken this side to the left side. So px dx will be limit n tends to infinity 1 by root over of 2 pi into 1 by n. Here n we have been considered as this one. See here, this value is np by x to the power 1 x plus 1 by 2 n cube by n minus x to the power this one. So your 1 by n we have been considered means n obviously it will be how much? Reverse of this one. That means x by np to the power x plus 1 by 2. Here n minus x by n cube to the power n minus x plus 1 by 2. Let this is your equation number 5. Let this is your equation number 4. Now we are going to first solve the value of n. Now n will be evaluated by considering ln. ln n. See here n contains x and n, and x and n is very large, and if a very large number we are going to be handled, at that time it will be better that we are going to be consider log. Okay, so ln n we have to consider as n is related to n and x which are very large. Considering ln equation number 5, this is our equation number 5. So equation number 5, you write equation number 5. So now ln n logarithm of n will be this one. Ln of this one means here it will be written as x plus 1 by 2 into ln x by np plus here it is n minus x plus 1 by 2. It will be n minus x plus 1 by 2 into ln n minus x by n cube, right? So here we consider the expansion only. So so first we have to substitute the value of x and n minus x, whatever we have been found previously. The x value is your this much, np plus z into root over of np cube, and n minus x is this one. First we have to substitute these two values over here, that is np plus z into root over of np cube plus 1 by 2, and here you can see that, so here we have been substituted the x value equal to this much, n plus z into root over of np cube, and here also we have been substituted this value. So you just put this value over here divided by np and np got cancelled, we found 1, and this value divided by np, that means we can get this one, np q root over by np is nothing but q by np root over, okay, z into q by np root over. So we found ln by substituting x value this much, we found 1 plus z into root over of q by np plus here n minus x value is how much? Is this much. We have to substitute over there, n minus np minus z into root over of npq. So simply I substituted simply, okay. So here n minus z into npq root over this one. I haven't substituted this well, nq minus z into root over of npq, okay. So nq minus z into root over of npq plus 1 by 2 as such it has been written over here, and ln into n minus x is considered to be this one divided by nq. So this will be 1 minus z into p by nq root over, okay. Now here we kept this term as such into this one, ln of 1 plus x. Ln of 1 plus x can be expanded this way, that x, that means this one, z into q by np root over minus 1 by 2 square of this one, 1 by 2 square of this one minus 1 by 2 square of this one, means 1 by 2 z square q by nq, right, plus 1 by 3 cube of this one, that means zq uh, to the power 3. Already 1 by 2 is there, so 3 by 2, and other terms here we not considered, because we want up to z to the power 3 is enough for our calculation. Okay, then here you concentrate that this term as such I have been written over here. Then ln of 1 minus z is going to be expanded as minus z, that means minus x minus z into p by nq root over minus 1 by 2 square of this one is nothing but your z square into p by nq minus 1 by 3 zq, that is your p zq, that this q. Okay, 1 by 3 cube of this one will be zq into p by nq to the power 1 by 3 and so on. Right, here we have been considered the multiplication, simple multiplication. Carefully you have to watch, this line is important. This line multiplication is important. See here, np is multiplied with this term will be how much? Will be, see here, n divided by root over of n is here, so you are going to get here, see np is there, root over of np at the denominator, so you are going to get root over of npq, and z is there, z is there. Okay, next np is multiplied with this term, how much we are going to get? Minus 1 by 2 z square np, here denominator is your np, got cancel, q is there, q is there. Okay, then np multiplied with this one, here you can see that this term z into root over of npq is multiplied with this one, this term, how much we can get? 1 by 3 1 by 3 z to the power q, sorry, this np is going to be multiplied with this term, how much we are going to get? 1 by 3 1 by 3 zq, and here you can see q to the power 3 by 2 q to the power 3 by 2, here you can see np to the power minus 3 by 2, this is np to the power 1 will be how much? np to the power minus 3 by 2, and this is np to the power 1 minus 3 by 2 plus 1 will be minus 1 by 2, that means 1 by np root over. Same thing it has been written over here, root over of np. Okay, then we have to consider multiplication of this term z into root over of npq into this one will be how much? You can see with this one, this term with this one first will be how much? You can see that z into z square, and here you can see that np root over got cancel, root over of q, here root over of q will be only q. Right, now we have to consider this term multiplied with this one will be how much? 1 by 2 z into z square is your zq, here you can see that np root over, so denominator will be automatically np root over, and this is your q to the power 1, this is your q to the power 1 by 2, so q to the power 3 by 2. Right, so here we are considering up to z to the power 3. So if I am going to multiply this term with this one, it will be z to the power 4. So I am not bothering to multiply this with this one, I have to multiply 1 by 2 with this one, with this term. Okay, 1 by 2. I left up here, and again I started to multiply 1 by 2. 1 by 2 into this one will be how much? 1 by 2 z into q by np root over. Then 1 by 2 into this term will be minus 1 by 4 z square q by np. Okay, exactly same way we have to consider the multiplication of this one with this. So nq multiplied with this one, we found minus z npq root over nq multiplied with this one, we got 1 by 2. Here nq got cancel, z square is there, z square p. Here we consider nq multiplied with this one, so it will be how much? 1 by 3. Here nq to the power 1, nq to the power minus 3 by 2. So automatically it will be nq to the power minus 1 by 2, that is your root over of nq at the denominator side, and p to the power 3 by 2, p to the power 3 by 2. So as I told that we are going to be consider up to z to the power 3. So here we have to stop to multiply this one. Then we have to consider this term minus z root over of npq multiplied with this one will be plus z square nq got cancel, pp. So root over of p will be p. Then this term with this one will be how much? Will be how much? This term, this one with this. So it will be plus 1 by 2 z into z square zq. Here you can see nq and nq root over got cancel. So automatically nq root over will be at the denominator, and here p to the power 1, and here p to the power 1 by 2. So p to the power 3 by 2. Then if I am going to multiply this term with zq, it will be z to the power 4. I am not interested. I have to multiply this 1 by 2 with this one minus 1 by 2 z root over p by nq, and 1 by 2 with this term will be minus 1 by 4 z square p by nq. Okay, now carefully you do this. Okay, carefully you have to multiply these terms. Okay, so now is equal to, you can see that many terms are going to be cancelled out. See, this is plus z root over of npq minus got cancel. Here 1 by 3 zq p to the 1 by 3 p to the 1 by 3 by nq root over here. Okay, here you can see here minus 1 by 3 zq p to the power 3 by 2 q to the power 3 by 2 minus 1 by 3 z to the power 3, but here denominator root over of np root over of nq. Okay, now other two terms here you can consider. These two terms not to be cancelled, just keep in your mind. Here two terms you can found minus 1 by 2 z square q minus 1 by 2 z square p. Here z square q z square p, and here you can found minus plus 1 by 2 z q by np, 1 by 2 z p by np root over, and here 1 by 4 z square p by nq q by np, like that. So here we can consider these two terms first, that this one and this one. So we can take common as minus 1 by 2 z square, minus 1 by 2 z square, we can found p plus q. Okay, then another two terms we can consider here. Another two terms z square, this one and this one. If we are going to consider take common z square among these, we can get z square into p plus q, right? Then plus, if you are going to consider these two terms, you are going to be get here z z by 2 root 10 taken outside, so it will be q by p minus p by q by p root over minus p by q root over, right? So same thing it has been written, p by q root over minus p by q by p root over minus p by q root over. So here you can see this term is contains 1 by n term, and other terms you consider this one, you consider this one, consider this term, consider this term, consider this term, any term you are going to consider except these two, these two, these two terms and these two terms, all terms contains 1 by n. Here 1 by root over of n, and other terms whatever we are going to get, uh, these terms will be contain 1 by root over of n terms. So in general I written plus terms belongs to 1 by root n. You just write terms having 1 by root over of n. Okay, terms having 1 by root over of n. So now limit n tends to infinity, ln capital N will be equal to how much? Here you can see z square plus z square p plus q, which is equal to 1. This is also 1 minus 1 by 2 z square plus z square will be half z square plus terms of 1 by root over of n. Now if we are going to consider limit n tends to infinity, these all the terms whatever you have except this term is going to be 0, because n tends to infinity means 1 by infinity will be 0. Then that means the terms having 1 by root over of n, this term or all other terms whatever we are going to get, these all the terms is going to be 0. So limit n tends to infinity n, we found e to the power z square by 2, right? Now equation number 4, where is the equation number 4? Here equation number 4, we here found that limit n tends to infinity 1 by n, limit 1 n tends to infinity n value we found this one, how much? E to the power z square by 2. This value we are going to be substitute in your equation number 4. We are going to get that limit px dx equal to 1 by 2 pi root over into 1 by n value we found e to the power z square by 2 into dz. The limit px dx will be equal to 1 by 2 pi root over into e to the power, this gone to numerator, minus z square by 2 dz. Previously we found in our discussion that x is directly depends on z. Here you can see x, here np are constant, z is directly depend upon x. Here also directly depend upon x. So if it is so, the limit n tends to infinity px dx 1 by 2 pi, instead of z we can write e to the minus x square by 2 dx, right? So here you can see dx got cancelled. Whenever n tends to infinite, the pmf will be called as pdf. So fx will be equal to 1 by 2 pi root over into e to the minus x square by 2. So this is nothing but what? This is nothing but your pdf of normal distribution having mu equal to 0, sigma equal to 1. That means we can write 1 by, instead of sigma, see in general form the pdf is nothing but 1 by sigma into root over of 2 pi. So here we got 1 by 2 pi. That means we can write 1 by 1 into root over of 2 pi. This 1 represents the standard deviation is 1, and here e to the minus x square by 2, that means in general it has to be written as x minus mu to the power 2 by 2 sigma square. So here mu is how much? If only x square is there, that means mu is your 0. So x minus 0 to the power 2 by 2 into 1. So having the range is minus infinity to plus infinity, and here z, the variate is your nothing but x minus 0 by 1, because x minus mu by sigma, so x minus 0 by 1. In general if we are going to consider, it will be z will be equal to capital X minus mu by sigma. or the value of x, capital X is nothing but x, are the x values are x, so x minus mu by sigma. So f of x such that mu sigma will be equal to, instead of 1 we are going to write sigma 1 by 2 pi root over into e to the minus x minus mu whole square by 2 sigma square minus infinity to infinity. So here you can see that this much whatever we got, this is nothing but your normal distribution itself. This is your normal distribution, or you can write this is the proof of your binomial distribution by following the condition that n tends to infinity and having p and q is not to be very small, it follows the normal distribution. So in general we have been modified the equation, this equation we have been modified to this one, but this is your last expression. Up to this much you can write in your exam. Okay, so this is your normal distribution having mean is your 0 and standard deviation is 1. So in general we can write this one. Okay, so this is all about the proof of your normal distribution as a limiting form of binomial distribution. So watch carefully this video and write down the note, and ready for the next class. We are going to discuss prove that for normal distribution mean, median and mode are all of same value. And here one thing I forgot to say, that normal distribution can also be obtained as the limiting case of the Poisson distribution with parameter lambda tends to infinity, but this topic is not inside your syllabus. Here I left this one. In some other day, some other, with the help of the some other video, I will be prove this one, but not now. But in our next class we are going to discuss this one. Okay, so thank you so much for watching this video. Thank you.